So part one of our video cut me off right here, so we're going to continue with Faraday's constant, 96,485 coulomb per 1 mole of electrons. And that's going to let your moles of electrons cancel. Now, again, we're trying to get to a time value. So think up here, we have a conversion factor that relates coulombs to amp seconds, and that's where our time factor comes in. So we know that 1 coulomb is equal to 1 amp second. So that's going to let our coulombs divide out. So now remember, we're just looking for seconds. So that means we got seconds on top. Okay, so we need amps to cancel. So this is where the other information they gave us here. They gave us that 50 amps was the current. So you need amps to cancel, so you need it on bottom. So we're going to put the 50 amps on bottom so that it will divide out. This lets the amp unit cancel with the amp unit. There's nothing on top here. Okay, just like here, there was nothing on bottom. We're using our units, letting them guide us. So now we got 25 times 2 times 96,485. And then we're going to divide that by 24.31 and divide that by 50.0. Now again, go back to your problem, look at your sig figs. We have 3 sig figs here, 3 sig figs here. So we want to round this to 3 sig figs. Now on my calculator, I got 3968.9. But since we need 3 sig figs, I'm going to round it to 3 sig figs right here. So we're going to round it to 3970 and don't put a decimal. So 3,970 seconds. That's 3 significant figures. All right, let's look at number 3. Here they've given us the half reaction. They want us to calculate the mass of cerium in kilograms, so be careful there. You want the final answer in kilograms, not grams. Produced in 10 minutes when a current of 4,000 amps is used. All right, so for this one, we're going to look, we have a 1 to 3 to 1 ratio with the half reaction. I'm going to start with the 4,000 amps. Now, of course, for this problem, when we get our mass, it's going to end up being in grams, but then we just need to remember to convert it to kilograms. So we're going to get grams of cerium. All right, so we need amps to cancel, so let's use that relationship again between amp seconds and coulombs. We know that 1 amp second is equal to 1 coulomb. So that's going to let your amps cancel out. So right now we have coulombs per second. So now we're going to have to somehow use this 10-minute factor here. So we got the time right now is in seconds, so we need to get it to minutes. So let's work on that time factor. So let's get seconds to cancel. We know that 60 seconds equals 1 minute. So now, voila, I have it in minutes. Seconds cancel here and here. So now you got coulombs per minute. Now they told us 10 minutes pass, and this 10 minutes only has 1 sig fig, so just keep that in mind. 10 minute. This lets your minutes cancel. Minutes divide with minutes. Nothing goes under that. All right, so right now, the only unit that hasn't canceled is coulombs. So there's your coulomb. We got to get to grams. We need a mass. So this is where we need to relate the coulombs to the moles. So we're going to use Faraday's constant again. So we need coulombs on bottom. So here's the coulombs here, so we need on bottom. So we need 96,485 coulombs equal to 1 mole of electrons. So that's going to let the coulombs divide out with the coulombs. Now I've got moles of electrons, so let's get those to cancel. According to this equation, there's 3 mole of electrons for every 1 mole of cerium. All right. So this is going to let your moles of electrons cancel. So now I've got moles of cerium and I need grams of cerium. So we're almost there. So we need the atomic mass of cerium. We need grams of cerium on top, 1 mole on bottom. So this is the atomic mass of cerium. 140.12. So again, we multiply all the numbers in the top row and divide by the bottom. So here, for this, we're going to get, when you multiply it out, 1,162 grams of cerium. Now remember, they wanted it in kilograms, and we do need to round it to just 1 sig fig because of that 10 minutes only has 1 sig fig. And so does the 4,000 amps. So we're going to use kids have dropped over from our metric conversion chart, and we're going to go from grams backwards 1, 2, 3 with our decimal. So if you move this decimal back 1, 2, 3, we end up getting 1 kilogram of cerium. Now I'm going to leave the last two problems for you to do on your own, but I will give you the final answers. So for number 4, the final answer should end up being, we need 1 sig fig on that, so it should end up being 600 coulombs. And for number 5, your final answer should end up being 1.4 grams of lead. I'll let you kind of work those out using some of the strategies I've shared up on the first 3 examples. I will just kind of point out, just in case you have a problem with the half reaction. The half reaction here, since this is lead 2 bromide, is going to be the lead 2 ion. So it's going to be your lead, Pb, the solid, forms Pb2 plus because it's lead 2 plus 2 electrons. So you have 2 moles of electrons here. All right, so these 2 problems will end up being part of your homework for tonight. Make sure you finish those up, and they need to be turned in for homework. Okay, we'll talk about these some more in class next time we meet.